Yeah. We at war. We at war with terrorism, racism, but most of all, we at war with ourselves. God show me the way because the devil's trying to break me down. You know what the Midwest is, young and restless, might snatch your necklace. The next these might jack your Lexus. Somebody tell these who Kanye West is. I walk through the valley of the shadow where death is. Top floor, the view alone will leave you breathless. Try to catch it, it's kinda hard getting choked by the Texas, yeah, and I check the method. They be asking us questions, harass and arrest us, saying we eat pieces like you for breakfast, huh? Y'all eat pieces. What's the basis? We ain't going nowhere but got suits and cases. A trunk full of
The amount of energy generated from a bullet is extremely impressive. Although it is impossible for us to determine exactly how much energy the expanding gases generate, we know that a minimum of 2,471.6 joules is required for the firearm to operate properly. As you can see, the amount of gravitational energy is insignificant compared to the kinetic energy that is generated.
We cannot accurately measure the amount of energy dissipated during the internal ballistics phase, so we have set an arbitrary value of 666 joules to represent the dissipated energy.
These charts show that it is accelerating at a high rate of speed. The position graph is increasing at an increasing rate, the velocity chart is increasing at a constant rate, and the acceleration chart is constant at an extremely high value.
Similar to the linear data, the rotational data shows just how extreme the bullet's movements are. With a 1 in 7 twist, meaning that for every 7 inches in the barrel, the bullet will make one full rotation. We can determine that upon exiting the barrel, the bullet will be rotating at 33,551.4 radians per second. And an even more impressive, some 31.25 million radians per second while in contact with the expanding gases.
Compared to the mass of the projectile, which is 62 grains, or 0.00401 kilograms, it has a very high momentum because of its high velocity. When it leaves the muzzle, its momentum will be 3.79 newton seconds.
During the external ballistics phase, the bullet leaves the muzzle to begin its flight. In this phase, gyroscopic motion is important because the bullet creates less wind resistance and is more accurate, whereas a tumbling motion would be less accurate. The bullet will maintain its momentum throughout the course of the flight. Because there is no acceleration, therefore there will be no impulse applied to the momentum. As we see with the actual position versus time and velocity versus time graphs, we see that the slope is almost linear. This is due to the fact that there is air resistance and other elements on the bullet. Assuming that all air resistance and all friction is negligible, this is what the graph would look like, more of a linear slope. And your velocity would stay constant throughout the whole flight. Also, the acceleration would remain at 0 since there is no acceleration at flight. Once the bullet is in flight, the total energy is divided between linear kinetic, rotational kinetic, gravitational, and dissipated energies. The magnitude of these depend on the position of the bullet during flight. Once the bullet leaves the muzzle and halfway to the target, most of the energy is in the linear kinetic with some dissipated energy. There is also rotational and gravitational energy during this stage, although it is very small in magnitude. Halfway to the target and right before impact, most of the energy is in the linear kinetic with very little in the rotational and gravitational energy. During flight, the bullet will stay in flight until either the force of the earth pulls down on it or until impact. In this phase, no horizontal acceleration exists. Therefore, according to Newton's second law, the force acting on the bullet is the gravitational force. While the bullet is in flight, the earth pulls down on the bullet, and in turn, the bullet pulls away from the earth with equal force. But because the mass of the bullet is very minuscule compared to that of the earth's mass, the bullet will fall to the earth.
Terminal ballistics is when a projectile hits a target, usually involving humans or living targets. It is often referred to the stopping power of the bullet on living things, which is also proportional to the caliber size. Like any object in motion, there will always be forces acting upon them in one form or another. When a bullet hits a target, there are two forces being applied on it. There is a force from the earth to the bullet and a force from the target to the bullet.
How fast the bullet stops after impacting the target will depend on the density of the target. If it hits a target that is equal in density, it will penetrate the length of the bullet. It will be less affected by softer targets, as you can see by the slow motion clips.
In the horizontal diagram, the bullet will be accelerating at an enormous velocity. As soon as it hits the target, the bullet will automatically start to accelerate the opposite direction. In the position graph, it shows how much distance the bullet is covering in a very short amount of time until it hits the target. The velocity graph shows how fast the bullet is slowing down at a constant rate when it hits the target. The acceleration graph shows that the bullet is accelerating in the negative direction when it hits the target. In this energy bar chart, the linear kinetic energy of the bullet is
1,796.88 joules.
The rotational kinetic energy is 8.72 joules, and the gravitational energy is 0.063 joules. All of this energy will dissipate almost instantaneously upon impact of the target. As soon as the bullet hits its target, it will automatically start a process known as the tumbling effect. The tumbling effect happens when the bullet penetrates the target. It rotates 180 degrees from where it came from in order to inflict maximum damage.
I've cut the block into 2 equal halves, taking the knife, running this direction over the top, centering it over the perceived bullet track, made a pretty good cut. I'm going to show this in a couple of different segments based on what I'm seeing already. I think I can give you the best presentation using that approach. Here's the entry point. This is the left side of the block, and you can see it's just a clean path where the full metal jacket is running to about the 4 1/4, 4 1/2 inch mark, and then it expands violently and quickly. This cavity is running about 2.75, maybe 3 inches in length. And if you dig in there, here we go, if you dig in there without really pressing down, that's about 1 inch in depth. And obviously you can see a small lead fragment away. This is so with the first 4 inches is cut away where that bullet was just simply coming in. Then you have that expansion. That is the permanent stretch cavity. And by the way, I have found some fragments here at about the 8 inch mark. Do you see it? There's the outline here. And then here on this half of the block, right there, you see it? That is the temporary stretch cavity. I haven't seen that in handgun testing. I know it's there. It's a lot smaller. I just haven't seen it, haven't been looking for it. But that is amazing. You can see where the shock waves branched out in this area, and obviously it was here toward the front of the block. So from here on the left over to the right, that's about 8 inches, and then it goes into about 8 inches. That's going to hurt.
While this video has given some keen insight to the basics of ballistics and firearms in general, there are actually many more variables to consider. There are many different types of bullets. For example, a full metal jacket, meaning a soft, dense core coated with a harder metal, will be less affected by the target than a hollow point, which is pictured second. Hollow points are designed to flatten out upon impact to prevent the round from continuing through the target and possibly injuring anyone behind the target. Also, the twist rate, which is discussed in the internal ballistics segment, will vary the rate at which the bullet spins. There is also rounds which have varying amounts of gunpowder. This will significantly change the acceleration, which will in turn change the muzzle velocity. Even if the load is the same, if the same round is fired out of a different weapon with a longer barrel, it will increase the amount of time the gases are in contact with the projectile, effectively increasing the muzzle velocity. That is just the tip of the iceberg when discussing physics of ballistics. Temperature, humidity, elevation, barometric pressure, and even the rotation of the earth have significant impacts on the flight of a bullet. The latter is known as the Coriolis effect. Because the earth is rotating underneath the round, long-range rounds fired along any axis besides the horizontal will have to compensate for the change in position of the earth.
It starts with one thing, I don't know why. It doesn't even matter how hard you try. Keep that in mind, I designed this rhyme to explain in due time. All I know, time is a valuable thing. Watch it fly by as the pendulum swings. Watch it count down to the end of the day. The clock takes life away.